Hi, geometry students. This is Mr. Hanke, and I want to talk to you briefly about solving proportions if you need a brush up. So here's our first problem, and if I were a guessing man, which I am, I would guess that you probably learned how to do this sort of problem by sort of like, oh, I'm going to take those two numbers, and I'm going to take those two numbers, and I'm going to multiply them together, right? So 8 times x equals 3 times 24. So 8x equals, I'll do that for you, that's 72. And so divide by 8, x equals 9. So there's a problem with this method in that few of you could probably explain why this works. And that's not because you're unintelligent, but because you were only taught this trick and not the underpinning, the mathematical underpinning. So the answer is correct, but I would advise against doing a maneuver that you don't know why it works, because at a certain point it becomes not useful. So let me show you two more mathematically sound ways to attack this problem. In this case, we can think about scale factors because 8 goes cleanly into 24. I'll work on the left here. So I know that 8 times 3 is equal to 24. So if I multiply by 3 in the numerator as well, I'm really multiplying by 1. I'll show you that in a second. So times 3. So 3 times 3, x equals 9 again. If we wanted to see that algebraically here, then it would be times 3 over 3, which is really 1. Okay, so that's how the scale factor works out, both with sort of like scale factor notation and the more algebraic notation. Now, the other way that I think is probably the most serviceable way for all situations is by solving by undoing. Okay, so what we're going to do is every fraction is really a division problem. So you see 3/8. That's the same as saying 3 divided by 8. So to undo 3 divided by 8, we need to multiply by 8. Sorry. And I'm just going to put an over 1. It's technically not needed, but when I'm multiplying fractions for my own eyeballs, it helps to see like numerators and denominators in all the terms. So that means we are dealing with 8x over 24. And that equals now 3, right? Because the 8 over 1 cancels out the dividing by 8. It's sort of like 10 plus and then minus, plus 3 minus 3. 10 plus 3 minus 3 is sort of the same thing we're doing here. All right, so now we're going to undo the dividing by 24, and we're going to undo dividing by 24 by multiplying by 24. And then it ends the same way. Okay, but both of these versions of work are, I think, better because like the mathematics is on the page. Like here, there's a trick and an algorithm that you know works, and I would guess that a lot of you who know this maneuver get it right like every single time. So the need to really stop and think about it seems inconsequential. But in both of these, it tells me you understand the mathematics at stake in this problem. Okay, so here's another version, which is only different in that the variable is in the denominator in one of the expressions. Same maneuver, though. So 4, like we could figure out a scale factor to get you from 4 to 5 or 5 to 4, and that's not actually the worst, but I want to show you this maneuver in action again. So I'm going to undo the division. I'm undoing dividing by 7. So, and then I'm going to undo dividing by x by multiplying by x. And then normal algebra maneuvers. And then we get, I mean, honestly, 28/5 is the right answer, but I know some of you like to change it. So that's equal to, you could change it to an improper fraction. You could change it into a decimal. Potato, potato. The important part is the maneuver where we're undoing the division twice. And so I'm going to give you one more example that looks just a little bit scarier, but still behaves exactly the same. Okay, so yes, going from 7 to 12, I could figure out a multiplier that, 7 times some number gets me to 12. But I want to show you the maneuver just one more time. So I'm going to undo dividing by 7, this 7, by multiplying by 7. All right, so then we have x plus 5 equals 49 twelfths. Let me show you that one more time, that over 1, okay? And then let's just go ahead and undo it. There are other ways we could simplify 49 twelfths and then subtract 5, but I want to show you the undoing step just one more time. So times 12, I'm going to undo dividing 12 by multiplying by 12. Well, I can do that over here too. That whole thing, that whole term, x plus 5, gets multiplied by 12. So 12x plus 60 equals 49. I'm going to subtract 60 from both sides. Okay, so 12x equals, negative 11. Negative, is that going to be okay? The answer is, yeah, no problem. So x is equal to negative 11 twelfths, which would seem to be problematic, except in that numerator, we're then adding 5. So to do some addition for you, so negative 11 twelfths plus 5, that is going to be, 4 and 1/12. Okay, and that sort of tracks because like 7 twelfths is a little bit over half because 6 twelfths is half, and so 4 and a little bit over 7 is also going to be a little bit over half because half of 7 would be 3.5. So that works for us. Anyway, that's a maneuver that works. This undoing division once or twice is a maneuver that works in all proportional solving. And so it's what I would recommend. But if you have any questions, obviously ask your teacher.